Nanotechnology is technology done at an extremely small scale. To put things in perspective, the thickness of a single sheet of paper is 100,000 nanometers thick. So people often envision things such as this concept art of a little robot zapping a bacterium. But this um, this is from science fiction. In fact, science fiction has often embraced the concept of very, very small things, from Fantastic Voyage from 1966 to the more recent Ant-Man films. Science fiction completely loves miniaturization and tininess. Also, there's conspiracy believers who think that they're small nano robots who are being injected into people's bodies and modifying the DNA, such as in this concept art here. But this is not realistic. So today on Craig Explains Stuff, I'm going to explain what nanotechnology really is and what it can actually do. Now, first, a little history. This sort of small scale stuff was first talked about by Richard Feynman in 1959 in a speech he gave that was published as There's Plenty of Room at the Bottom. And in his speech, he conjectured that one day in the future we would be able to build things atom by atom at an atomic scale with little tiny robots that were small enough that they would be able to manipulate individual atoms. Now, this paper is often cited as an influence, but in 1959, when he gave the speech, it actually had almost no impact on science. And it wasn't until it was rediscovered later that it actually had any impact. Also later, the term nanotechnology was coined by Norio Taniguchi in 1974 in his paper on the basic concept of nanotechnology. Now, this paper was like Feynman's, also not very widely received. But his work was widely received, and he's actually well respected in the field of making nanomaterials. So, if all of the early work was basically overlooked, when did nanotechnology really get going? And the answer is 1981, because in 1981 there were two big advances in nanotechnology. First, Eric Drexler rediscovered Feynman's paper, There's Plenty of Room at the Bottom, and he used that as the foundation for his own paper, Molecular Engineering, an approach to the development of general capabilities for molecular manipulation. And in that, he expanded on Feynman's work to state that we actually did have the technology to make nanoscale machines that could build things at a very small molecular level and perhaps even the atomic level. So, whereas the previous two papers that I mentioned were mostly overlooked, this paper managed to capture the imaginations of a lot of scientists and engineers at the time, and this paper has been cited well over 600 times in other people's work. The second thing that happened in 1981 was the invention of the scanning tunneling microscope. This microscope was able to actually use quantum tunneling to take images of things at the molecular and even the atomic um, scale. This is a picture of one from the 1980s. A more modern one looks a little bit more like this one. This is the scanning tunneling microscope that's currently at the University of Texas. And these two events led to a big explosion in nanotechnology, specifically the 1985 discovery of fullerenes. Fullerenes are a type of carbon atom where you can get 60 of them and arrange them in a circular grid that ends up sort of looking like a soccer ball. And they're named after Buckminster Fuller, who was a United States architect who used a structure similar to this to build geodesic domes. So fullerenes are important because you can actually scale fullerenes up to be actually quite large comparatively on the scale. They're hollow on the inside, and you can put other nanoparticles inside of a fullerene. And fullerenes were then later modified into carbon nanotubes. And this happened in 1991. And carbon nanotubes are important because if you go down the length of the nanotube, they're actually very good conductors and can be used as semiconductors. But if you go across the width of the nanotube, they're actually a really good insulator. So they have a wide variety of purposes at the very small level. And carbon nanotubes and fullerenes basically kicked off an entire new field of science that was influenced by Drexler's 1981 paper. Now, it's worth noting that one of the discoverers of fullerenes, named Richard Smalley, actually ended up getting in a very public argument with Drexler, and their argument was conducted through a series of letters to scientific journals. And in these letters, Smalley basically said that Drexler's work was naive, that atoms and molecules do not work like bricks. You can't just stack them and assemble them with a machine, no matter how small you make the machine, because they obey rules of like covalent bonds, and when you have to start worrying about quantum physics, they can't be stacked like bricks. And Drexler responded saying that Smalley was misrepresenting his work. Um, so he continued on and is widely influential in the field of molecular nanotech, whereas Smalley is a lot more influential in nanochemistry and nanoparticles. So, how far along is the development of these nanobots and nanorobotics? And unfortunately, I'm going to tell you the truth here, they're not very far along. Because to some degree, Smalley was right. You can't actually just assemble um, machines out of atoms at this sort of scale. So, what they ended up doing is using long proteins, because it turns out biology has already made long molecules that can be used for this, and you can control where they go through enzymes. So it turns out that nanorobotics is actually a lot more similar to chemistry than it is to machines. You can get a long protein strand to sort of wiggle so that its ends appear to walk and traverse down a carbon nanotube. And you do this by using enzymes so that the protein will want to move in that direction. So this is a diagram that represents that. So it appears to be stepping and walking down the nanotube. But this um, nanorobotics hasn't gotten very much past this. This still could be handy, especially if, for example, the big ball that here in this image, if you made it a fullerene and you made it large and put something inside of it, so it's actually carrying a nanoparticle down the tube. But it's certainly a long way from the nanobots that people envision and that people are concerned about. So if nanobots isn't really isn't really a thing that we have, then what have we developed through nanotechnology? And the answer is nanoparticles. And nanoparticles have actually gotten pretty far along. Three of them are actually in very heavy production, and I'm going to talk about those three right now. The first of which is zinc oxide. Now, obviously, when something is crushed down to a nanotech scale, it's not going to be visible to photograph like this. This is zinc oxide at a regular scale. And note that zinc oxide is very white on this scale. But if you crush it down, it no longer reflects visible light and is basically clear. But it still reflects UV and ultraviolet light. So the industry that really wanted a clear substance that would reflect ultraviolet light is the sunscreen industry. And um, nanoparticles of zinc oxide are actually quite commonly used for sunscreen. Many of you have probably put this on within the last year. If you look at the ingredient list, it will say that it has zinc oxide. In the United States, they do not have to specifically label if the zinc oxide is a regular size or if it's nanoparticles. But if the substance goes on and doesn't dry white, then it's probably nanoparticles of zinc oxide. A second chemical that's in heavy production is titanium dioxide. And titanium dioxide looks like this. And again, this is a larger version of the powder. And it also is clear. And it has several properties that also make it very good for sunscreen because it also reflects UV light, but it the titanium dioxide is also water resistant and sweat resistant. So when you see a sunscreen that says that it has water resistance, it's very likely water resistant due to the titanium dioxide. And again, because titanium dioxide is white, many companies want the nanoparticle version of the titanium dioxide so that it will go on clear. This is actually important not just for sunscreen, but for various cosmetics. A lot of cosmetics actually promote themselves as being of having sunscreen or of being water resistant, and this is also often due to nanoparticles. And the third nanoparticle that's in heavy production is silicon dioxide, also called silica, and this is very well known to most people as quartz. The more pure and more clear quartz is, the more likely it is to be pure silicon dioxide. And quartz is the second most common mineral in the Earth's crust, and it's pretty evenly distributed across the world. So most of you viewers are probably pretty familiar with quartz crystals. Another thing that silicon dioxide is that many of you would be familiar with is that in many places, silicon dioxide is the main ingredient in sand. Now, this actually is not a picture of sand. This is a picture of silicon dioxide. So if you're used to your sand being sort of a yellowish color, then the sand that you're thinking of is probably silicon dioxide sand. If you live somewhere that has white beaches or beaches of a different color, it probably has a lot less silicon dioxide in it. Silicon dioxide nanoparticles are used for a lot of the same purposes that sand is used for, and that's making cement. Sand is one of the major ingredients in cement, and if you use nano sized silicon dioxide, then it actually makes the cement a little stronger when you've made the finished product. Silicon dioxide is also used to strengthen rubber. Now, many of you who have worked with cement before or seen the dry cement get poured into a cement mixer, you may be familiar with the fact that you typically are advised to wear a mask when you're pouring the dry cement. And that's because silicon dioxide is known to be a hazard. And that brings up our next topic. How hazardous are nanoparticles? And there's several diseases that may be associated with nanoparticle exposure. This is a little misleading because it says they are associated to nanoparticle exposure, but a lot of these, they aren't totally sure about these connections because the health and safety of nanoparticles has been actually fairly poorly studied. Now, for those of you who use sunscreens, it is known that zinc oxide and titanium dioxide cannot be absorbed through the skin. So, in that sense, those two substances are safe. But if you get a little bit of your sunscreen in your mouth, it is less well known how safe nanoparticles are if they're ingested. And silicon dioxide is already known to be a lung irritant, And this is actually worse if you have nanoparticles of silicon dioxide. And if any of these get inside the body, it's important to note that um, although your skin can keep these particles out, if you inhale them or if you ingest them, um, membranes inside your body and inside your throat, inside your stomach, inside your lungs, they readily absorb nanoparticles. So if you inhale them or ingest them, they are almost certain to get inside your bloodstream. And this is potentially bad um, because we, again, they're not well studied. We don't know if they build up inside your organs. We do know that they can pass something called the blood-brain barrier. The blood-brain barrier is usually considered a way to keep toxins that may have gotten into your bloodstream. It prevents them from getting into your brain. But nanoparticles can easily pass the blood-brain barrier. So if nanoparticles get into your bloodstream, there's concern that they'll get into your brain and possibly cause Parkinson's or Alzheimer's or some other neurological disease. But again, there's absolutely no proof of any of this. They're not they're not studied that well. But before you start going, oh no, maybe we should ban nanoparticles, it's important to note health benefits of nanoparticles. Again, if we go back to the fullerene, it turns out that the carbon 60 fullerene actually acts as an antioxidant inside the body. So it may actually potentially have health benefits rather than being a danger. So that also leads us to one more thing, because you could put a molecule of medicine inside of a fullerene. And in fact, that sort of thing does happen, and that helps target certain parts of the body. Now, nanomedicine is actually a very big field. Billions of dollars are being spent on it. And unlike nanorobotics, nanomedicine has actually gotten several medicines approved in the United States by the FDA and in other countries by their governing boards to determine whether medicines are safe. Now, one of the main reasons you would want to use a nanomedicine is for targeting, which is which is what this concept art is. It shows the targeting of a particular cell. And what sorts of cells we can target are cancer cells, because you can get um, small nanoparticles of medicine and you can encase them in a different type of molecule that's a biological molecule called a lipid. And you can actually use chemistry to make certain types of lipids that only dissolve around certain types of enzymes. And so you can make the medicine so that it only gets dissolved and released when it's near the cancer cells. And this is very important for people undergoing chemotherapy, because traditional chemotherapy will typically make the patient very, very sick, because any sort of medicine that's aggressive enough to kill cancer cells is also aggressive enough to kill other healthy cells inside the body. And if we can use nanomedicine to only release the medicine near the cancer cells and not release any medicine if it's not near a cancer cell, then the side effects of the medication are very much minimized. And like I said, a lot of these products are already on the market for certain types of cancers. Another use for nanomedicine is for organ transplant recipients. You can target the medicine in organ transplant recipients so that it helps them um, prevent organ rejection. And there's also at least one HIV drug that uses nanotechnology. So, in conclusion, nanomedicine has been a very big and beneficial use of nanotech. Nanotech is used for sunscreens widely and is actually very common. You almost certainly know somebody who's got nanotech cosmetics on their skin. But the popular version of nanotechnology being nanorobotics, that is basically science fiction. Most of that is still in the very early concept stages and is not a realistic fear at all. So I hope that you enjoyed this episode of Craig Explains Stuff. If you did, please hit the like button or please subscribe. I do have other videos where I explain other things. And I hope that you return, and I'll see you next time.